All right, here we are with lesson 8 on percent increase and decrease. So let's jump right in here. Jim works for a company that's willing to give him a 5% raise on his yearly salary at the end of every year. If Jim's salary starts at $45,000, what is his salary at the start of the second year? Well, the old method that we could use was where we take $45,000 and we find out what 5% is. So we're going to multiply this by 5%. So 5%. And that's going to give us the new salary. That's not true. That's not going to give us the new salary at all. That's going to give us the amount of his raise, right? So let's see. So what do we do here? We do 45,000 times 0.05. And when we do that, we get $2,250. But this is how much he got for a raise. That's not how much his salary is. So now we have to take his salary at the beginning of the first year and add the raise to it, telling us his salary is $47,250 at the beginning of year 2. Okay, so kind of, a two-step multiple equations here that we had to use. We can definitely do this in one step, and I highly recommend being able to do it. So let's look at method 2 here. What we're going to try to do is we're going to try and develop some sort of a system to not have to do too many equations and too many kind of we have to, over here we had to add and we had to multiply. So let's try to eliminate that and try to just get directly to the answer as quick as possible. And so one way to do it is to think of it like this. I'm starting with $45,000. And I know I get a 5% raise. So if I have this $45,000, I have to add to that another $45,000, or at least the percent of that. This is going to determine how much the raise is. So here's my starting amount, and here's how much the raise is. When I add them together, that should be exactly what I did over here. But let's break this apart a little bit. If I take this equation and I factor out a 45,000 from each of these terms, from this term and from this term, what I would have is 45,000 times 45,000 times what gets me 45,000? And the answer is 1, right? Anything times itself, anything times 1 is just itself. And 45,000 right here, if I factor the 45,000 out of this, well, I'm just left with this 0.05. So I have plus 0.05. In other words, if I simplify this even more, I would have 45,000 times 1.05, because that's what 1 plus 0.05 is. And now let's think about the number 1.05 for a second. Let's convert that decimal back to a percent. Okay, that percentage would be 105%. 105, so that's more than 100. So that means I have everything I initially started with and 5 more percent. Well, isn't that exactly what I'm trying to do? Have everything I started with and 5 more percent? So this right here, this 1.05, if you take and add 1 to any of these percentages, you're going to end up in this situation where you're going to be able to show the exact percent increase in one calculation. So let's try this again. Let's see how we do this. We take, let me erase this. From scratch here, what we would do is we look and we say, okay, where's my starting amount? It's this, $45,000. And then I look at my percent and I find out if it's an increase or decrease. And his salary goes up, right? He gets a 5% raise on his salary every year. So it's going up. So first I figure out, well, a little side work, 5%, that's the same thing as 0.05. Then I do this, and I add the 1 to it. So I say 1 plus 0.05. Okay, if you don't like looking at it like that, you can think of it this way. You can say, well, again, we have to think a little bit. The raise is 5%, but I have 100% of what I already make plus another 5%. So in other words, I get 105%. And so as a decimal, 1.05. Okay, so no matter, you can get to it a lot of different ways. The idea, though, is to make sure you're adding in that 100%. Okay, so once we add in that 100%, we end up with 1.05 as a decimal, or 105%, 1.05. And if I multiply these two together, I get 47,250. So there's a little bit of prep work to set this up. Okay, it's really not that difficult though, and it's certainly a lot less calculations on this side for method 2 than it was on method 1. Of course, either one will always work. You're more than welcome to use method 1, but we should start being able to recognize method 2 and see how it works and why it works, and it's really the quick, easy way to get to where you're trying to go. So let's see how this might shake down with percent decreases. If a cup of coffee is cooling its temperature down at a rate of 10% per minute, if the coffee starts at a temperature of 210 degrees Fahrenheit, what is its temperature after 1 minute? Okay, so the old method would be, let's take its starting amount, 210 degrees Fahrenheit. We're going to multiply it by the 10%, and that's going to give us how much it has cooled, right? So 210 degrees Fahrenheit times 10% as a decimal is 0.1. And that's going to tell me 21 degrees Fahrenheit. That's how much it's cooled, right? So now I have to take the starting amount and subtract from that, right, because it's getting cooler. Subtract from that the 21 degrees, and that's going to tell me 189 degrees Fahrenheit. Again, takes me 3 calculations to be able to get to here. We can do something very similar for the percent decrease. Okay, there's going to be one kind of fundamental difference here. Once again, I'm going to start with the 210. That's my starting amount. And if I think about this, what do I need to do? I need to subtract from the initial amount whatever the percent of the decrease was, right? So this 210 times that 10%. Well, that's exactly what I have here, right? This 210 times the 10% is this number, and this is the starting value. So starting value, percent of decrease. I can do the exact same thing though that I did earlier and say, well, I could factor out this 210 and start with that and then multiply it. 210 times something got me 210, that's a 1. I have the minus sign, and if I factored a 210 out of this, I'm left with just that 10%, or as a decimal, 0.1. And I can clean this up even more and say 210 times 1 minus 0.1 is 0.9. And then I can do 210 times 0.9 and see what I get. Now, let me see, I have to grab my calculator. And of course, it ends up being 189. And we knew it was going to be 189 because it's the same exact thing. So let's do this one again from scratch and see how we can just jump right to getting this answer in one equation. All right, so the first thing we want to do is we want to look at what is the starting value. Here you go, 210 degrees Fahrenheit. That's going to be important, 210 degrees Fahrenheit. Then what we want to do is we want to figure out if it's cooling at a rate of 10% per minute. That's how much it's going to cool, right? So how much of it's going to be left as being, I guess, hot would be the way to say this. How much of it's still going to be hot? Well, if 10% cooled off, then the other 90% of it is still hot, right? So try to think of it in that terms, right? So if we had 10%, you could say, well, 100% minus that 10% gives me 90%, and that's actually what I'm looking for. Right? I'm not looking for how much it cooled, I'm looking for how hot is this thing still. All right, so that's one way to get to it. This is all in percentages, of course, and then you would have to change that 90% to 0.9 in order to use it in this equation. Now, you could do it that way, or we could look at it as I have 100, you could write it right in there, 100% minus 90%, or you could say 1 minus 0.1, and you're going to get that 0.9 that same way. Okay? Let me think. Another way you can look at this is you could always just do it this way too. 210, the starting amount, minus the amount that it cools. Right? So this value here represents the amount that it's cooling, which is this equation. This represents the starting value. If I take the starting value and I subtract from it the amount it cools, that gives me where it is right now as far as its temperature. Okay, so there's kind of a lot of different ways you can think this through. It does require a little bit of thought, but it always will work. So if you're doing a percent decrease, you can always start with 1 and subtract the percent it gives you. And so in other words, you would end up with 210 degrees Fahrenheit times 0.9. And in one equation, you'll get your answer. Okay, so the goal of this lesson here was to show you there are multiple ways to be doing these. There is kind of a quick, easy way to do it, or you can always resort back to doing multiple equations if you need to. Okay, but trying to really understand and wrap your head around the percent increase and decrease model using one equation is going to be very beneficial as we move forward. Okay, well that's everything. We're going to work a lot more with this in class, so don't worry if it was a little confusing. We're going to do a lot more of this in class the next day, and we'll see you then.